Hello friends, welcome to Learner's Planet. Friends, this is Geometry Workshop and in this session we'll be discussing triangles and quadrilaterals. And I would recommend you before coming to the workshops you should attend the basic sessions and advanced session of geometry because in this session we'll be going for the postmortem of this triangles and quadrilaterals. We'll be discussing concepts, derivation and problems based on triangles and quadrilaterals, right? So let's begin this session. Friends, before we proceed further, I would just suggest you just have the basic knowledge of coordinate geometry, trigonometry and geometry, right? Here, coordinate geometry, as far as coordinate geometry is concerned, you must be knowing the distance formula between 2 points. Suppose x1, y1 is a point and x2, y2 is a point. Then distance between these 2 points is suppose d, then d square is equal to y2 minus y1 whole square plus x2 minus x1 whole square, right? This is the distance formula. Okay, next is division, right? Suppose I have a line, maybe A and B, and this is the point C that divides this line in the ratio m1 m2, right? Coordinates of this point is x1 y1 and x2 y2, right? Coordinates of this point may be suppose x and y, right? So x is equal to m1 x2 plus m2 x1 upon m1 plus m2, right? Similarly, y is equal to, this is x, this is y is equal to m1 y2 plus m2 y1 upon m1 plus m2. This is called internal division because C is in between A and B, not exactly at the center but between A and B, right? If m1 is equal to m2, that means if C is exactly at the center of this line, then m1 is equal to m2. In that case, x is equal to x1 plus x2 by 2, right? In that case, m1 will be equal to m2, so they will be cancelled and finally you are left with x1 plus x2 by 2. So coordinates of center is x1 plus x2 by 2 and y1 plus y2 by 2, right? This is internal division. If the division is external, suppose point A is here, B is here and C is here, and this ratio is say m1 and this say m2, then the only change over here is you have to put up minus sign over here, right? m1 x2 minus m2 x1 upon m1 minus m2, and y is equal to m1 by 2 minus m2 y1 upon m1 minus m2. That is external division, right? So this is the formula for internal division. This is the formula for midpoint if coordinates of 2 points are given, and this is for external division. Okay. Similarly, if two lines are parallel, suppose a1x plus b1y plus c1 is equal to 0, a1x plus b1y plus c2 is equal to 0. They represent parallel lines where coefficient of x are in proportion, coefficient of y are also in the same proportion, but c1 and c2 are different, right? So these two lines represent parallel lines, right? In that case, what happens? The distance between these two lines, suppose these are the parallel lines, this distance we can call it as a perpendicular distance also. So this distance is given by c1 minus c2 upon root of a1 square plus b1 square. C1 minus C2, you need to take the positive distance, so you can take the magnitude. Whatever is the bigger quantity, you have to deduct smaller quantity from it, right? So modulus of C1 minus C2 by coefficient of x square plus coefficient of y square, that will give you the distance between two parallel lines, right? This is absolute distance. Okay. Now some important definitions related to triangles. The first is the basic definitions of triangles that you are already knowing. That's scalene triangle, isosceles triangle, right angle triangle, equilateral triangle. So I'm not going to repeat them. First thing is median. Median is actually, I just draw over here. Suppose I'm having this triangle A, B, C, and this is P, Q, R. Now P, Q, R are the midpoints of BC, CA and AB respectively, right? This point is, this length is equal to this length, right? So AP is, AP, CR and BQ are known as medians, right? AP, CR and BQ, these are actually medians of this triangle. That means the line if we match the midpoint of this side to the opposite vertex, then it will form a median. This point, that is the concurrence point of all the medians, is known as centroid. We represent it by G. You can take any other symbol as well. So this is actually centroid. Now the specific thing that you need to memorize over here, it's AG is to GP, that's the ratio is 2:1. That means this centroid divides median in the ratio 2:1 if you take it from the side of vertex, right, from where you are dropping the median. Okay, so this is 2:1, right? So that's very important. Okay, next is we can say circumcenter, orthocenter, in-center. I take orthocenter. Orthocenter is actually concurrence point of altitudes. Suppose this is the diagram ABC, then AP, BQ and CR, suppose they are altitudes. Remove this. These are altitudes. So this point is actually concurrence point of all the three altitudes. Okay, so this is known as orthocenter, right? Concurrence point of all the three altitudes is actually orthocenter. Okay, next is, I will write over here, concurrence point of altitudes. Okay, next is, I take circumcenter. Now friends, circumcenter is actually concurrence point of perpendicular bisectors. What is perpendicular bisector? See this line that is bisecting this line as well as perpendicular on this line, right? Do not get confused between altitude and perpendicular bisector. Altitude may or may not bisect the other side, but perpendicular bisector will be perpendicular as well as it will bisect the other side, right? So this is suppose PQ and this is R, right? So CQ, BR and AP, these are perpendicular bisectors, right? So perpendicular bisectors, their concurrence point is actually circumcenter. We tell this as circumcenter because from this point, this length and this length, all the three lengths are same, right? And if you put a compass over here, you can very well draw a circle. That means a circle can be circumscribed, right? I'm not able to draw a neat diagram. This circle is known as circumcircle because it is circumscribing this triangle, and that's why we call it as a circumcenter, right? So this length and this length, all of them will be equal obviously, and this is known as a circumcenter, and these three lengths are actually radii of this circle. Okay, so I hope you are getting me. Next is in center. I just draw the diagram for that also. Now friends, in-center is actually concurrence point of angle bisectors. This is the angle, this is the angle, and this is the angle. Now this part is equal to this part, right? That means what is happening? We are drawing angle bisector and they are meeting at this point. So this is actually in-center. Right? That means concurrence point of angle bisectors. You must be knowing that. All the definition should be clear because they will be definitely used while we will be solving the problems, right? So concurrence point of angle bisectors is known as in center, and with keeping this as a center, we can draw a circle that will be inscribed in this triangle, right? You can see this circle that is inscribed in this triangle, and all the three sides of this circle this triangle will be working as tangent to this circle, right? This is tangent, and this is tangent, right? So this is the incenter. Okay, you got the difference between circumcenter. Through circumcenter you can draw a circumcircle. Through incenter you can draw an incircle. Okay, incircle inside the triangle, circumcircle outside the triangle. Okay. Now, since you have got all the definitions related to this triangle, we take some other, discuss some other formulae and concepts. Maybe this is triangle A, B, and C. The side opposite to this A, having the length as A, this is B, and this is C, right? These A, B, C are lengths of B, C, C, A, and A, B. Okay. Now, the next thing is I introduce P. P is actually semi-perimeter, right? Perimeter will obviously be A plus B plus C. Semi-perimeter will be A plus B plus C by 2, right? So P is semi-perimeter for this triangle and its value is A plus B plus C by 2, right? I suppose S is the area of triangle. Okay, R is circumradius, right? We have discussed circumcircle, circumcenter, so this will be circumradius, and the small r is suppose in radius. Now certain formulae or concepts you need to keep in your mind. The first thing is sine rule, right? Sine rule is A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to 2r. That r is actually circumradius. Okay, radius of the circumcircle precisely, you can say. Okay, and this is the sine rule, and similarly we have cosine rule. So cosine rule is what? Cos, suppose we take cos A is equal to B square plus C square minus A square by 2BC, right? Similarly, cos B will be what? A square plus C square minus B square by 2AC. Similarly, you can find out cos C. So these are going to be important, that sometimes they are used to find out the solution of the triangles in quick manner. Okay. Now friends, using sine rule or sine formula, we can even calculate the area of the triangle, right? Area of any triangle can be given by half A into B sine C, right? Half A into B sine C, or half B into C sine A, or half A into C sine B, right? So two consecutive sides or two adjacent side and sine of angle between them. Using them you can calculate the area of the triangle, right? If you equate all of them, you'll be getting this expression. Okay, so that's pretty easy. You must be knowing sine rule, cosine rule, and how to find out the area of triangle using sine rule. Okay. Now to calculate the area of any triangle when all the three sides are given, no angle and is given, and the triangles are maybe this isosceles or maybe this scalene, then you can use the Heron's formula. I just write it over here. Right, this formula we use to calculate area of triangle. So that's S, that is area of any triangle, is equal to P minus A, P minus B, P minus C. That is the P is the semi-perimeter over here that we have just discussed, right? P is the semi-perimeter. Okay, so put up the value of A, B and C over here, first of all you need to calculate P, then put up the value of A, B, C, you'll be able to get the area of that triangle, right? Now in that case, in the case when A, B and C are equal, that means the triangle is equal. In that case, area will be root 3 by 4 A square. A is the side of that triangle, right? If you put A is equal to B is equal to C as A, you'll be getting this expression. Okay, so that is the area of the triangle when all the three sides are equal, or we can say equilateral triangle. Okay, now the other relationships that you must be knowing are S is equal to PR, where P is semi-perimeter and R is in radius, or we can say S is equal to ABC by 4R, right? Here R is circumradius, here R is in radius, ABC are sides of the triangle, and P is the semi-perimeter that I have already told you, right? So these are the basic things which I have discussed so far that you must be knowing, so you'll be able to solve the problems in faster manner. Okay. Friends, in the basic triangle session, I have already discussed the other basics, or you can say theorems related to similar triangles, related to congruence, angle bisector theorem, and other theorems I have already discussed, right? So that's, I have already told you, before coming to this workshop, you need to attend the basic session of triangles. So you'll feel comfortable while we'll be discussing various concepts, because these concepts are actually having more depth than the basic sessions. Right, so you should feel comfortable while you come for this session. So do attend that particular triangle session before you come over here. Now we'll be taking some problems, and we'll be discussing the problems in detail. So while we'll be discussing the problems, you will get to know some more concepts involved over here, right? We'll be taking the problems from the previous CAT papers also, so you can relate the concept very well, right? So let's begin. Let's take the first problem. Now we try this simple problem. Here, the length of the base of an isosceles triangle is 9 and the vertex is 60 degree. Find the length of the bisector drawn to the lateral side. So I just draw the diagram. So here this is an isosceles triangle, and this angle is 60 degrees. So one of the angle must be 30 degree, right? Now the length is 9, and since this is an isosceles triangle, this angle bisector and median, both of them will be same. So we can assume this length to be 9 by 2. This length is x that we have to calculate. Now relationship between this and this, right, that we have to find out. Now what? See, in case when this is an isosceles triangle, median, angle bisector and altitude, all of them will be same. So this is actually 90 degree. Now you can use the relationship, the trigonometric relationship between this and this. This is actually perpendicular, this is base. So the relationship between perpendicular and base is given by tan theta. So here theta is 30 degree. So tan theta is 9 by 2x, right? Tan 30 degree is 1 by root 3. So x is equal to 9 root 3 by 2, right? That is the length of angle bisector. Okay, I hope you are clear. Now, in an isosceles triangle, the vertex angle is 120 degree and its area is 16 units. Find the length of the base of the triangle. Now, once again, the same logic I'm using over here. This is angle bisector as well as altitude as well as median, because it is an isosceles triangle, right? So this angle is 60 degree, right? Now assume this length to be x, this length to be x. Now I don't have the length of the base as well as the length of the altitude, right? So I cannot equate it to area, right? So what I'll be doing, I'll be using sine formula to find out the area of the triangle, right? Now what's that? Half x into x, that is x square into angle between these two is 120 degree. So half x square sine 120 degree is equal to half base into altitude. is equal to actually 16, right? All area is already given to us. So half x square into sine 20, 120 is 16. So from there we can calculate the area of this, this length x. Sine 120 degree is cos 30, cos 30 is root 3 by 2, right? So x square into root 3 by 2 into 1 by 2 is 16. So x is equal to 64 upon root 3 square root, okay? Or we can say 8 upon 3 raised to 1 by 4. Now we want this length. So suppose this is y. Relationship between these two, that is perpendicular and hypotenuse, is given by sine theta. So that's sine 60 degree. Sine 60 degree is root 3 by 2. So sine 60 degree is equal to y by x, right? And x is what? 8 by 3 raised to 1 by 4, right? So y will be double of that because this is the half length and we have to calculate the full length. So precisely we have to calculate 2y. So 2y is equal to 8 root 3 upon 3 raised to 1 by 4, right? 2y is equal to 8 root 3 upon 3 raised to 1 by 4. That will be the length of the base. Okay, I hope you are clear. Now here in a triangle MNP, Mn minus Np is 18. What is the perimeter of this triangle, right? A very simple problem. We'll be using angle bisector theorem right away. See, this is angle bisector. That means Mn by Np is equal to Mx by Xp, right? This is what angle bisector theorem. I write Mn by Np is equal to Mx by Xp. Right, mx and xp are already given, so mn and np we can calculate. So y upon y minus 18 is equal to 28 by 12. So 3y is equal to 7y minus okay, so 4y is 126. So 2y will, or we can say 2y will be 63. Then what we have to find out? Y plus y minus 18 plus 28 plus 12, right? So that will be the perimeter. So that's 2y minus 18 plus 28 plus 12, right? 2y is what? 63. So 63 minus 18 plus 28 plus 12, that you have to find out. That you can do easily, right? So this is the use of angle bisector theorem. I hope you are able to recall that. So friends, in the next session, we'll be taking some difficult problems. Do revise the concepts discussed in this session and the basic sessions of geometry. So you'll be comfortable in the next session. So in the next session, even I'll be introducing circles as well with the triangles. Okay, so we'll be taking the problem in combination with the quadrilaterals, triangles and circles, all of them inclusive. We'll be using the concepts of coordinate geometry, trigonometry as well, right? So let's meet in the next session once again. Bye bye.